Okay, so basically this problem is tricky but easy. Let me explain. We're given these fences, bricks in form of fences of a particular length of 1 unit and width of given unit of 5 and other 3, 3, 1. We'll be given this particular fence's length and the unit and the breadth will be 1 for each and every one of them. And for the given fences, we need to find out whether we can turn it upside down or not and it remains the same. Which basically means that in this case, you can see in this example, it is 5, 3, 3, 1 and 1. So when we flip this thing, which means if we flip it, we will get this. This 1 goes here, this 1 goes here, this 3 and 5 goes there. So basically, let's denote it as A, B, C, D and E. So this here it is A, B, C, D and E. So basically, we'll be given these fences in this way, and if you look at it like this, it's 5, 3, 3 and 1. Right? I'm writing again. So see how these two are the same. But this is of length 5, the length of the fence is of unit 5 and the breadth is 1. Here if you look at it, it's tilted, but if you look at it properly, it goes like this. This is how it would look. Theoretically, even though it's flipped across, it still looks the same, which is 5 units because there are 5 elements, and here it's 3 because there are 3 elements, C, B and A. For this also it's 3, C, B, A, and for this it's A and A. So it's 5, 3, 1. So these two are equal. Now, in the question they'll be given whether, in the question if it's given a particular number of fences, we need to find out whether flipping that fence will give us the exact same combination of lengths. So now that we understood the question, let's look at a few points which are necessary before we continue, which is that first things first is it's always been decreasing order, which means that A and so on. So A, which is the first fence, will always be greater than B, which will be greater than or equal to B, which will be greater than or equal to C. You can see here 5 is greater than 3 and equal is greater than or equal to. So this is the condition, the first condition. There are no other conditions we have, it's just this one. So now how do we get the answer for this solution? Which means that how do we know whether flipping this thing will give us the exact same combination of lengths or not? We could do one approach, which is that we can individually break down each and every one of the numbers we have, which is that for 5 we can break it down to 3, this is 5, this is 3, or we can just write it like this actually. And break it down. We start from 1, which is 1, the second one is also 1, third one is 3 ones added, the fourth one is 3 ones added, the fifth one is 5 ones added. If you look at it like this, you taken these numbers from the ending. Now you can add these things, you will get 5 and 3 and 3 and 1, 1. You can do that. You can check whether the answer is correct or not, matches this thing or not. The problem is, the number is really big, like if instead of 5 it's 10,000. In the question it's given that the values can range from 1 to 10 power 9. So if the value is 10 power 9, you have to break it down to 10 power 9 once. We should add each and every one of them to check, which will most definitely give you a time exceeded error. So in order to actually solve this thing efficiently, of course. So in order to solve this thing efficiently, what you're supposed to do is think of a small logic. It's a small, nice, neat trick that we can use to solve this thing, which is that, look at it. 5, 3, 3, 1, 1. If we flip it, we get this, right? Now let me show you how this thing works. In order for that, we'll just rub this diagram off. So yeah, let's take, since this is an algorithm, we need to generalize everything. Let's take it as A, B, C, D, and E. Now these are the corresponding lengths of each and every fence. Now let's say we convert it and we get some other combination of fences which are dash 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 and dash. We don't know what they are. Okay, we don't know the lengths of them. We need to find out and check whether if it's true or not. So now, if you flip it, for this case, if you flip it like this, what will you get? Okay, still we don't know the lengths actually. So we'll just write A, B, C, D, and E. So now we return the lengths of them after we switched them, which is what do we say? After we tilted them. So after we tilted these fences, we still have the lengths here. So this is just now this. So right now, this area, this will most definitely be 1. The length will be 1. For example, if there are like 3 blocks, if there are 3 blocks, these 3 blocks will be length 1 in this case. Or however much number of blocks are there, lengths of 1 unit blocks are there, they all will be 1. The length of the entire block from this to this will be 1. This entire block will be 1. Now, we know that, right? Because there is only one block, and since I said the breadth of each block is 1, so in this case, the breadth of this block will be 1. So, I think I wrote it the wrong way. The breadth of the block is 1. So, this is length 1. So, from here to here, it's length 1. Now, in order to calculate how long this length 1 is, for how many units the length 1 occurs, we can just calculate it by calculating A minus B, right? Because this is A and this is B. If you want this length, you need to subtract B from A to remove this thing off, which we'll get by doing A minus B. Now, which means that the number of blocks here will be equals the number of blocks of length 1 will be A minus B, right? Now I think you're getting the answer. I think you get the intuition right now what I'm trying to say, but let me explain it to you completely. So basically, from here on, the length of the block is in this case 3. If we just remove this thing, for example, just for context, we remove this. Yeah. So if you remove this, from here on, from this particular length, it's 2, right? So the length of these blocks will be 2 till here, from here. So how to calculate that? We don't need A now. A is forgotten because we found out the number of blocks of length 1 is A minus B. So let me write the general formula actually. Basically, blocks of length 1 is A minus B. Now for blocks of length 2, we need to calculate. For 2, it will just be same as 1, just B minus C. And for 3, it's C minus D. And for 4, it's D minus E. So, now we can find out the lengths of the blocks, the number of lengths of blocks if we flipped it. So basically, if you want to fill these values, it's basically the thing we'll get is A minus B here, because the smallest block should always, even if you flip it, the smallest block should always be at the end and the largest should be at the beginning, the largest fence. So this is A minus B, which is the number of blocks of length 1 will be A minus B, which is here. Actually wait, no, I think I explained the wrong way. Look at it like this. We don't need to find out whether what is the reverse, what will be the length, or how should I say it? Let me explain it to you like this, okay? Um, let's take that the number of blocks of length 1 is a minus b, right? So from these, however many of them, a particular number which is a minus b, whatever number we will get, those many number of ones will be there. So if a minus b is 2, we'll get 2. If a minus b is 3, we'll get 3. So yeah, I mean, I think it's getting a little difficult with this generalization. So we'll just get back to our example, which is 5, 3, 3, 1, 1, right? So we'll write it here too. I mean, I'll leave it like that. So a minus b is 2 in this case, which is 5 minus 3 is 2. So the number of ones, what we get from this information is it's 2. So the number of ones we'll get if we tilt this thing, if we tilt this particular fence structure, the number of ones we'll get in the resulting structure will be 2, which means that obviously since we start from here, we'll get 2 ones. Now for 2, b minus c is 3 minus 3, which is 0, which means that after we tilt it, the number of 2's we'll get will be 0. There won't be any 2's. So we'll go to the next one, which is 3. The number of 3's will be 3 minus 1, which is 2 again. So the number of 3's we'll get, if we flip it, is 3. I mean 2. So we'll be adding 3 and 3. Now finally, for the last one, in this case, how do we calculate the last one? For 4, or if you want for 4, it's 0 because 1 minus 1 is 0. So for 5, since there are 5 blocks here, there will also be 5 blocks here too. So how do you calculate the number of 5's? It's just simple. The number of 5's will be equal to this number. So number of 5's will simply be equal to e. Why is that? Simple. If you look at it, this block is the final block. After this, there are no blocks at all. So the number, the least, what I'm trying to say is, this final block, the length of the final block determines the length of this block, because if this is 2, then this will be 2, right? What I'm trying to say is, let's assume that it's 2. Then the resultant block will be, this should also be 2 in that case, will be 2 of length 2. That will be 3, that will be 5. So there will be 2 blocks of length 5. There will be 2 blocks of length 5, which means we'll get 5 and 5. So if it's 3, we'll get 3 blocks. If it's 4, we'll get 4 blocks. So basically, the last block, which means the last block we'll get in this normal one, determines the number of 5's we'll get, or number of the last digit we'll get. Just in this case 1, because this block determines, because in this case this is the least block, like which means it's the smallest block, which means that however big the smallest block is, which means the minimum, however big the minimum number is from this array, will determine the number of 5's it will have, because since the number count is 5, count here is 5, so 5 into how long this block weighs will determine how long the number of will determine the number of 5's. So in this case, the number of 5's is 1. So now we determine that both the original and the flipped version of the fences will give us the same result. Now how do we write this in code? Simple actually. Yeah, so now to write this on code, let's take our array. Okay, so 5 marker is not writing properly. I'll use this one instead. Five, 3, 3, 1, 1. Right. So now we don't need the flipped array, right? We don't need the resulting array we'll get if we flip this fences. We just need to check, will flipping this thing give us the same number as this or not. That's it, right? We just need to check it. We don't need the array. We don't need the actual array. Codeforces did not ask us to return the array. So what we'll do is, since what we're doing here is we're taking the count, right? In order to get 1, we're doing 5 minus 3, which means it will give us the number of ones we'll get. So in order to check whether it's true or not, we can check for each number of numbers we have is the count of 1, which here is a count of 1. Is count of 1 in this, which we will get is 2, equal to the count of 1 here? Yes, it is. The count of 1 is 2. Basically what we'll do is, in order to achieve this, we'll take a map, which means we'll take a map which contains a number of frequency of each element, basically. So basically we'll get 3 as 2 and 5 as 1. Now this will take n time, O of n time, for going through each iteration and counting the number of elements, the frequency of each element. Now the second part we'll do is, after this is, what we'll do, we'll iterate through each element of the array again. What we'll do is, we'll iterate from this particular first element to the second last. Now what we'll do here is, for each element I, let's take this I, ARR of I, this will be ARR of I plus 1, right? So what we'll do is, we'll subtract this number with this number, since that's what we're doing, right? 5 minus 3 will give us the number of ones. So what we'll basically get is AR of I minus AR of I plus 1, is it equal to map of count. Here we can increase count. We'll initially have count as 1, and we can increase count, increment count. Yes. What I can do is, I can increase it. The if condition is this. This is the condition we should be checking. For each and every subtraction we get, in this case it's 2. Is 2 equal to the map of count? What is count here? 1. So is it equal to 1? Is it equal to count map of 1, which is 2? Yes, 5 minus 3 is 2. So what happens is, it continues. But if it's not equal, it means that if we flip it for some number, for example, let's take 2, some random number, if we flip it, what happens is, we won't get those number of 2's if we flip it. For example, if there is a 2, let's take, I don't know how many, for 2 I think let's take 2, maybe we'll get, oh here it's 1, maybe if we subtract it we'll get 1, right? 3 minus 2 is 1, yeah. So yeah, actually it's a perfect one, but 3 minus 2 is 1. Just don't think about the rest of this thing, we're just trying to check this condition. 3 minus 2 is 1, which means that you will get 1. What is it? 1, 2, yeah, 2 is 0, right? In this case 2 is 0. 1, 2, 3, 4, 5. Basically in this case 2 is 0. 3 minus 3 is 0. So this means that in this case, for this normal fence construction, the number of 2's is 1, but if you flip it, there won't be any 2's. Now whether the 2's position is correct or not we don't need to think about that, because it will always be perfect. The positions can't, even flip it, A will always be greater than or equal to B and will always be greater than or equal to C. This will go on. Even if you flip it, it's the same way. You can't change that position. So if 2 is not there, it's not there. That's it. The position, you don't need to check it. It basically means that if the condition is not true for some I and count, for some I and count, if we take, if A of I minus A of I minus 1, I plus 1 is not equal to the map of count, it means that you can't flip it and get the original fence, which means then we can break it. And we can keep adding the count till here. Let me just rub this thing. 3, 4. So till 4 we'll check it. We'll get everything correct. We'll stop here. So the for loop will be from 0 to I minus 1 into length of array minus 1. So now once we get out, all we need to do is check if array of the last element minus 1 is equals to map of count. Since like count will increase for each iteration, after count increase we'll get 5 at the end, and as soon as we get 5 we'll get out of this loop, so we can add map of 5. If map of 5 is 1, in this case it's 1, yeah. If everything is correct, if all these conditions are satisfied, which means that this condition we don't get into it, which means that array of I minus array of I plus 1 is equals to map of count, and array of minus 1 is equals to array of is equals to the number of 5s we have, map of count which is 5. That means that if you flip it, we'll get the same fencing, which means you can return yes in this case. And if it's not, then which means if this condition is false at any point of time, we can break it. Even if this case, if it's wrong, we can break it and we can return no. It's basically a simple thing. If you understand the intuition, it's basically that if you're given it like this, any number of fences, we flip it, what we'll get is the first one is determined by the subtraction of this and this. So the block of length 1 determine the blocks of these lengths subtraction, and the block of length 2 is determine the blocks of subtraction of these two, and the block of length 3 is determine block of subtraction of these three, and the block of length 4 determine the length of this one. That's how you'll get it. You don't need to, this will take n time again, basically O of n. Totally it will be O of 2n. The time complexity will be O of 2n here. You'll get it. But it's pretty good comparing that the first brute force solution was for you to take 10 power 9 and you break it down into 1, 1, 1, then 10 power 9 times, and you add those things vertically. It will take you more than n square. It will take you more than n square. It will take you 10 power 9 operations to do it. And the time complexity, I think it was 3 into 10 power 5. Not time complexity, the exact time. The number of test cases we have is 3 into 10 power 5. Which means that you can do it in O of n or O of log n. N log n. N log n. So that you can do it in any of these two times. You can do it in n square. And forget about this one, it's not even n square, it's more than n square. So yeah, that's basically this solution. I don't know how to end this video. It's been a long time. I don't think anyone's watching this, but thank you.